In this part of the lecture, we will go over some of the mathematical concepts that I am sure most of you are very familiar with. For example, things like ratios, percentages, and proportions. The use of math. Galileo wrote, "Philosophy is written in this grand book, the universe, which stands continually to open our gaze. But the book cannot be understood unless one first learns to comprehend the language and read the characters in which it is written. It is written in the language of mathematics, and its characters are triangles, circles, and other geometric figures, without which it is humanly impossible to understand a single word of it. Without these, one is wandering in the dark labyrinth." Basically, the language spoken by physicists is mathematics. So that means a working knowledge of mathematics is essential to the study of physics. Some important mathematical tools are reviewed in Appendix A. At this point, I would recommend that you all turn to Appendix A and look through Appendix A and try to recall all the mathematical concepts that you know. The language of math. Algebraic symbols are often used to express numbers. Together with numbers and units, all physics phenomena can be described completely. A number represented in an equation has no meaning unless it is attached with a unit. As an example, think of a number 2000. What does it mean? Well, it means absolutely nothing. But let's say I attach a $sign to it. What does it mean now? It means you now have $2,000. Now let's completely change it and attach the unit of meters with it. What does it mean now? It means 2,000 meters. Let's change it further. Let's associate the word seconds with it. Now if you attach the word seconds with it, it means it's 2,000 seconds. The same number, 2,000, is now used in multiple different scenarios, and it comes up with multiple different units and multiple different meanings. So one of the things is being very, very careful when defining your answers as well as your units. Now before we proceed any further, I have a word of warning for you. There are not enough letters in the alphabet to assign a unique letter to each quantity that we will encounter. For example, the letter V is used in multiple contexts. V is used for volume. V is also used for potential difference. V is also used for velocity. So now avoid attempting to solve problems by picking an equation just because it seems to have the correct letters. Try to understand specifically what each quantity, each symbol means when you are talking about an equation, and understand your given situation precisely. If you take things out of context, you will run into trouble. So as promised, we need to talk about ratios. But in order to talk about ratios, we will talk about factors first. In the language of physics, the word factor is a very important one. Factor is a number by which a quantity is multiplied or divided when it is changed from one value to another. So let's look at this example. Y equals mx plus b. This is an equation. What is an equation of? Yes, it is an equation of a straight line, right? In this case, this equation has three terms, y, mx, and b. Now the term mx, the x in that term is being multiplied by a factor m. More than likely that factor m is a numerical value, say 4. Those together make up terms. Another example, y equals x over a plus c. In this case, x is multiplied by the factor 1 over a. Or, in other words, you can also say x is divided by a factor a. The terms x over a and c are added together. So all the terms together make up an equation. An equation always has an equal sign in the middle. So let's talk about ratios now. If, let's say, we want to say that the power of a radio transmitter has doubled over the last 1 hour, we can say that the power of the transmitter has increased by a factor of 2. So in that case, if P naught is your initial power and PF is your final power, then this can be defined as PF over PI equals 2. Notice that this number 2 does not have any units associated with it. That means that this number is a unitless, dimensionless quantity. And the unitless, dimensionless quantities are called ratios. Noting that both PF and PI, initial and final powers, have units, and those are both in this case are watts. Looking at another problem, if you were to look at this, SF over SI equals 1/2, what can you say about this equation? As another ratio example, let's look at this factor. If the concentration of the sodium ion in the bloodstream is half of what it used to be when we did the last blood test, we can say that the concentration has decreased by a factor of 2. Mathematically, all of these words that we have just written on the above line can be expressed as a single term SF over SI equals 1/2. Or even simply SF equals 1/2 times SI. So all of these words that were written over there are algebraically equals to the equation that I have written down over here. So that means that ratios and equations help us minimize the amount of writing that we need to do. The other thing that's important in physics are called percentages. So in order to talk about percentages, I'm just going to present you with this example. So let's say you put $10,000 in a CD and you leave it in there for 1 year. The annual percent rate that the bank gives you is 3.05. How much interest does the bank pay you at the end of the year? So this is a good question in order to solve for percentages. In order to solve all physics problems, this is what I would recommend that you do. You first read the problem, read it very carefully, write down all the given expressions that you have in that problem as a given. Then try to figure out what you already have, what you already know, and then try to apply that in order to solve these problems. So for example, in this problem, the problem says you put in $10,000 in your CD. So P naught, which is your initial investment, is $10,000. Note, I am putting a sign with it that shows me what the unit of these things is. It is very important that you remember the units. Okay? The other important thing after reading this question is the annual percentage that I need to worry about. So it's 3.05%. Okay? In physics or in mathematics, whenever you see the symbol for a percent, that means that you need to multiply this number by a factor 1 over 100. So basically, percent sign means multiply the number by 1 over 100. And if I do that, I get 3.05 times 1 over 100, which is 0.0305. Okay? That is now going to be my interest rate. If I was to put in $1 in my bank, this is how much money I will get back in dollars. But my initial investment was $10,000. Now how do I figure out how much money my bank is supposed to give back to me? And in order to do that, what I'm going to do is I'm going to multiply my annual APR percentage with my initial investment, which if I do the math, it's 0.0305 times $10,000 equals $305. This is the interest rate that I would collect after 1 year. So that means if I leave my principal sum as it is, and the bank gives me $305 more, what is my net income or my net profit at that point? Correct. It is absolutely, at the end of 1 year, I should see a profit of, or I should see my money grow to $10,305. See it? That's how you do the problem. First, you put down all the information that the question gives you. Then you look at the prior information that you already know, and then you solve the equations with this set. Again, now let's look on the flip side of the coin. So for example, if you have $5,000 invested in stock, let's say XYZ, and it loses 6.4% of its value today, how much is your investment worth?